Welcome to another episode of STEAM, Ins, and Arts, where we explore critical ideas, cutting-edge research, and conversations that continue to shape the future of STEM education. I am your host, Precious Sithole, a research assistant at STEAM and an honor student in STEM ICT at the great University of Johannesburg. And this is STEAM, Ins, and Arts, brought to you by STEAM, the Center of Advanced Learning Technologies in STEAM Education. Special guest with us here, Professor Joseph Krajcik, a distinguished science education researcher, director of the Create for STEM Institute, and university distinguished professor at Michigan State University. His work focuses on project-based learning, formative assessments, and improving student engagement in science education. He has received numerous international accolades, including the McGraw Prizes for Innovation in Pre to K-12 Education, and is currently serving as a distinguished visiting professor at the Department of Mathematics, Science, Technology, and Education at the University of Johannesburg. Welcome, Professor Joe. How are you this morning?
Thank you, Precious, for that very nice introduction. I'm doing well. Thank you. I hope you're doing good as well.
I'm doing my great self too. I'm doing great. Thank you so much, Prof. Would you like to tell us just a bit more about yourself, about the work that you've done so far, before we can get into today's conversation?
Sure. As you mentioned, I direct the Create for STEM Institute at Michigan State University. CREATE is actually an acronym, and it stands for Collaborative Research for Education Assessment and Teaching Environments. And the goal of CREATE is to bring together researchers from various disciplines, engineering, natural science, and education, really to try to solve some of the pressing problems in K through 16 education. So we do a lot of work in K-12. Most of my research focuses on K-12, but we also do work in higher ed. So CREATE is an organization, you might say a hub for innovation, where we're really trying to make breakthroughs in how to support kids in truly developing usable knowledge. Much of my work really focuses on trying to create learning environments that can really engage learners to really try to solve problems or make sense of interesting phenomena, and in doing so, really develop deep understanding of science ideas and scientific practices that they can actually use to figure out new phenomena or solve new problems as they develop in their lives. Lately, as you well know, Gen AI has really hit the scene. And so CREATE is also nowadays exploring how can we appropriately and responsibly use generative AI to really promote student learning, to really help teachers really develop students' capabilities, not to replace teachers, but really to extend what teachers can do.
All right. Thank you so much, Prof. That actually takes us to the depths of today's conversation, where we're looking at the intersection between project-based learning, science education, as well as artificial intelligence. You mentioned that the Create Institute also looks into the intersection of science education as well as learning sciences, right? Now, looking back at education and the work that you've done in this specialty, what is the one thing that we now understand and about how students learn that previously educators didn't necessarily pay much attention to or had strong understanding of?
Well, we've really, the learning sciences and educational research over the last 20, 25 years has really uncovered a lot of and has strong evidence for a lot of ideas on how we really can promote student learning. And I don't know if I can just pick out one, but maybe I'll mention a couple, because there's a couple of really important ideas. So one idea that I'll mention is, I started off my career, and of course this was more than 25 years ago, it was more like 40 years ago, as a high school science teacher. Actually, that was more like 50 years ago. But back then, the whole goal was really to try to engage kids in inquiry and discovery learning. And we really didn't have a good sense of how do you really support students in doing inquiry. We knew we wanted science classrooms to look a little bit more like what scientists really do, but we didn't really know how to do it. And lately, especially in the last 20, 25 years, we've really figured out that if we really want to engage kids in not just knowing about science, but actually being able to do science, we actually have to create learning environments that can really motivate them, show children, show learners that there's a purpose for learning what they're doing. But more importantly, not just saying, let's go investigate this, but very carefully scaffold the process of kids doing scientific inquiry. And in the past, we really didn't have, let's say 25 years ago, we were just starting to learn about the importance of breaking tasks down into smaller bits, you might say, that kids can really tackle. So we really learned a lot about how to scaffold learners in doing really challenging aspects related to inquiry. So inquiry is such a broad term, for instance, right? What does that really mean? And so if we even look back at what the framework for K-12 science education has done, it broke scientific inquiry into say, let's don't say just inquiry. Let's talk about the practices that kids have to engage in. And so right there we have a refinement, because rather than saying inquiry, we say, well, there's a variety of different practices. So we're breaking it down into asking questions, into writing scientific explanations with evidence, into modeling, into designing experiments. So that breakdown is really critical. But I'll give you another very specific example that was really important in my development, you might say, and that's supporting kids in writing explanations. I think you know that explanations is the foundation of what science is all about. So we really want to get students in classrooms to create explanations. We want them to develop explanations. Often in the past, it was always teachers who would give the explanations. Well, we really want kids to give explanations. So how do we do that? And when I first started this work back in probably 2000, I was doing work with Kate McNeil on a project called, we were trying to design materials called iQuest. And we really wanted kids to get involved in doing explanations. And so we wrote, the kids did an experiment. We said, now write an explanation for this. And kids didn't know what to do. They wrote one little tiny sentence. And the reason why, it sounds really naive that we did that, but that's what we did. They didn't know what to do. And so Kate and I were really trying to figure out, how do you do this? We actually walked into one of our teachers' classrooms in Detroit, Michigan. She worked, Kalanda Colson works for the Detroit Public School System. We walked in that classroom, and Kalanda really wanted to get her kids to do explanations, but she knew as an experienced classroom teacher, I can't just say write an explanation because they're not going to do anything. And so in her work, she broke it down into saying, okay, what's a claim you want to make? Do you have evidence to support that claim? And what's the scientific reasoning behind that? And so in Kalanda's work, she actually broke down the writing of scientific explanations in the claim, evidence, and reasoning. And that breakdown, which is a really important scaffold, like that's one way in which you can really scaffold learning, is really breaking a challenging task down in the manageable pieces, really helped us getting middle school kids and high school kids really to write more complete explanations. So we came up with this framework of claim, evidence, and reasoning to really support students in writing scientific explanations with evidence. So that's one example that shows the importance of careful scaffolding to really support learners.
Okay, so Prof, you mentioned that through this breaking down of and the scaffolding through just understanding how learners explain content, how they even describe or explain anything for instance, in the scientific class. So how did then that basis translate into your focus on project-based learning? How did you take that understanding and deepen that scaffolding into project-based learning?
Well, so the goal of project-based learning is to engage kids in a meaningful context, some some problem area that can really drive their learning. And in my work in project-based learning, it's always closely related to important learning goals that need to get covered in the school system.
Mm-hmm.
So we come up with a variety of different. We always start by saying, okay, what is it we're trying to get kids to learn? So we really look at the standards of the school district,
Mm-hmm.
or what we're trying to develop. If we're working with a school district or we're trying to design curriculum more widely, we always look at what are the important learning goals, and then from them important learning goals, we try to identify issues, phenomena that kids would really find motivating. So, for instance, it could be related to water quality, right? What's the quality of our water? Or how can we provide clean water for all the people in our community, which is really an important question. Lately in the United States, there's been areas where it's really become hot. And so we wanted to create a unit on kids understanding that when it takes energy to basically separate molecules or to break molecules, if you're going to decompose either molecules themselves, or if you're going to cause a phase change, that always takes energy, right? So we wanted to create a unit, because those are some important learning goals in chemistry. We wanted to create a unit on helping kids understand that it takes energy to separate things.
Mm-hmm.
And so because of the extreme heat that students have been experienced, communities have been experiencing in the United States, we came up with this question: how can we keep members of our community cool when it's really hot outside?
Mm-hmm.
So as they go about exploring that questions, kids do investigations. And as they do those investigations, we want them to write explanations to make sense of that phenomena. So why is it? So for instance, one possible explanation that they could come up with, one thing they experience is they notice that when you heat water, as the temperature as you provide heat, the temperature increases. But all of a sudden, it reaches the boiling point. So it reaches 100 degrees Celsius, and the temperature no longer increases. Why is that? Why is it that when you hit 100 degrees Celsius, you're putting all this energy into the system? The temperature isn't increasing. It's boiling, but the temperature isn't increasing. Where is all that energy going to? And so that's one of the first experiences that students have, to realize that it takes, once you get to boiling aspects, we have to figure out where that energy is going to. And we asked students to write a scientific explanation related to it. And of course, then they have to write a claim, they have to provide evidence, and they have to provide reasoning for what's going on. And so if we would just say write an explanation, that wouldn't be very helpful. But if we said, let's write an explanation, and if this is the first time they're writing an explanation, we say, let's break that down into a claim, evidence, and reasoning, that can really support the learners in writing strong scientific explanations. Now, the first time you're going to do it, it's still going to be a pretty weak. And so it's really critical as a teacher to give students feedback and continuously come back to explaining. You want to write a claim. Now, I should also mention, if you just say write a claim, that's not enough either. You really have to help kids understand what a claim is, right? So that's a
Sure.
further breakdown, right? Saying just write a claim, it's not enough. You have to support kids in writing what is a claim. And so they have to realize that a claim answers a claim basically responds to a scientific question by showing how one variable relates to another variable. And so we also work on that in classrooms, helping them understand what is a claim. So we're constantly breaking things down to help learners. And of course, if you break it down, then eventually you want to make sure you can remove all that breakdown, those scaffolds, and have kids write independent claims or explanations on their own. The same thing is true with reasoning, which tends to be the hardest part in writing a scientific explanation. But we break that down and say, look, at scientific explanations really try to show why the data you have really counts as evidence. And in order to show that, you really have to bring in ideas related to scientific ideas. So that's a scientific reasoning process. Why does your data actually count for data? Students have to bring in scientific principles and show why that data is that way. So we are constantly breaking down tasks so that they're finer and so that kids can perform them. But it's also very critical to eventually remove all those scaffolds so that kids can do it independently on their own. And we have fairly strong data that shows that if you don't remove the scaffolds, then kids can't do it either. They become dependent. Rather than being a scaffold, it becomes like a crutch, a permanent crutch. And so it's very important as time goes on that teachers remove the various scaffolds. Now you could see some of the you could see the value if all teachers had that perspective, because kids could be in 5th grade learning how to write explanations, and as they move to middle school, they're still practicing how to write explanations with a breakdown of claim evidence and reasoning, and they could do it in high school. And you could imagine if they're having all that practice from 5th grade to middle school to high school, they're really going to be a different type of learners, because they're really going to understand what an explanation is, and they're going to know how to write an explanation. But perhaps more importantly, they're going to be able to, when they look at the newspaper, when they read the news, when they hear reports, they're going to look for what's the claims that are happening. And they're going to look, is there evidence to support that claim? What's the reasoning the person that's used that claim? So understanding what an explanation is, looking for claims that have appropriate evidence is really an important skill. And by breaking it down and working with students with it over time can really promote their learning.
All right. Thank you so much, Prof. I'm looking at the fact that our concerns was more focused on taking away the scaffolding as time goes by so that learners gain that autonomy and independence. But let's look at the society that we're currently in, one that is dominated by generative AI, where now our concerns don't only lie in taking away the scaffolding, but it lies in how learners can simply take the questions that they take from the classroom, the inquiries that we give them in the classroom, and just go to AI and generate the entire step-by-step scientific inquiry process. So what are your thoughts on the impact of AI in scientific inquiry and knowledge among our learners?
That's a really important question for today's age. And if in fact we use AI in that manner, that people just go to AI and use it as an information source, we are misusing it as what its potential, and we're doing ourselves a disfavor. Because just by going to AI and asking it for information, we're taking all responsibility, all ownership away from ourselves. And that's not leading to learning. Just because I can ask a system to generate a response for me doesn't mean I understand anything. So, as many educators, I'm exceptionally worried about that scenario, that students use AI as an information source to respond to questions that they are supposed to think through, right? That's the issue. Students are supposed to use scientific reasoning to think through those questions, not give it to AI and hey, AI generated. AI can do a great job at it, right? I don't have to evaluate AI. That said, I would say that's a very inappropriate use of AI. But as educators, we have to consider what are the appropriate ways in which generative AI can actually help us both as learners and as teachers. And if we think of AI more as a cognitive partner, right? Think what a collaborator is, right? A collaborator is you go to them and they don't just tell you an answer. You sort of work together to figure something out. And so what we need to do is train AI systems, not so that they give us answers. And we can do this. We can train them. We basically can train AI systems not to give us answers, but to be our collaborators, to be our partners, to try to figure something out together. And when we're trying to figure something out together, that doesn't mean that someone just gives me the answer. We're doing a back and forth process, really trying to clarify our ideas. So hopefully in the world to come, AI will not just be an information source that students will go to, because we won't allow that to happen. What will happen is that AI will become a collaborative partner that can really support kids in understanding and making sense of complex ideas by asking good questions. So questioning is another really important scaffolding feature, right? If you come to me and say, Joe, I don't really get this. And I could say, well, tell me a little bit more about that, Precious, will you? I'm not quite sure what you mean. And you give me a response and I say, oh, I understand that, Precious. But what about this? Can you tell me more about that? So if we can create chatbots or AI systems that can really work collaboratively with students to help foster their thinking, then that's a good use of AI. So we want to really be careful. There are very inappropriate uses of AI, and certainly the information grabbing that unfortunately too many students are doing nowadays is very inappropriate, because they're doing themselves a disservice. They're not developing the scientific reasoning or the habits of mind to figure things out on their own. And we don't want that to happen. But we can we can train AI system, to be our partners, to be collaborators that extend what we can do, actually make us better at what we do. And that's what we want to do. For instance, I am working on a project. It's called Interactions, in which the whole goal of Interactions is really to understand the nature of a chemical bond and why things stick together. It's a very challenging concept for kids, actually, to understand what causes things to stick together and why things break apart, or how you break molecules and bonds apart. And so we have questions we give them, and we've actually trained a Gen AI system to give both appropriate and developmental feedback. So the students respond to an open-ended question, right? So for instance, one of the questions we have for the students is, there's an electroscope. I think you know what an electroscope is. It's a device that you can actually put a charge on, and then because you put a charge on it, you'll see leaves separating or coming back together again because of the charge flow. And it's a very tough idea for students. They see the scenario where this charge rod touches the top of electroscope, which causes the leaves in the electroscope to spread apart. And we ask, why is that happening? And so kids can put in a response, and we've trained the AI system so that it will come back and give a very appropriate, give students, it will respond to what the kids said. It will say something like, oh, I see you said that it has the same charge, and that's why the leaves, so the leaves separate. And so it gives some reinforcement to the kids on what they said. It recognizes what it says, but then it goes on further and it says, but what is it about? Why is it that they separated? So what is it about similar charges that actually cause the leaves to repel? And so it basically gives them a question that can drive their thinking further. Now, interesting enough, I stumbled through that. A chatbot is much more smoother than I am at coming back on the responses. So it actually really we've really trained the system. And this is not an overnight aspect. We've worked very hard at training the system to really to respond to what the students said, and then give developmental feedback that can really push them to the next level. So it takes time, but you can train our current systems to do this kind of developmental feedback. Now, our hope is that because this is our first time doing it, that we're actually learning and we're going to get better at it as time goes on. So we'll have to see. In fact, we had our first. I'm here now in South Africa, but yesterday in the U.S. we actually had 4 classrooms actually use the system, the whole system at one time, and so we gathered data on over 300 students the last couple of days. So it'll be really interesting for me to go back and see how that really worked. Did the system really able to push kids forward and having them give more complete responses? So it'll be pretty interesting to see what happens. So I think as science educators, we do have to be careful about how we use Gen AI. We don't want to use Gen AI as an information source. That's taking our ownership away from us. That's taking our autonomy away from us. That's destroying our opportunities to learn. But there are appropriate ways to use Gen AI to be a cognitive partner that basically can extend what we do, make us better. That's what we want it to do, right? Any tool should be able to make us better at what we do. You don't know this, but I love to do carpentry work, right?
Oh.
And so I can use a handsaw. I do a pretty good job with a handsaw. I've been using a handsaw for a long time. But when I use my table saw, I can cut a much straighter line. My table saw basically enhances what I can do. And that's what we want Gen AI to do. It's not that I want I don't want the table saw to build my table. I'm building the table, but it's helping me cut my board straighter. And the same thing with Gen AI. I don't want Gen AI to generate the scientific explanation. I want the student to write the scientific explanation. But Gen AI can help me, can help students, can basically make their capabilities better. That's how I want Gen AI to do, to help us as a partner to do our work better rather than replace what we do.
Mm. Okay, thank you so much, Prof. I mean, from the perspective of the development side, we can then attempt to train these AI systems to be more Socratic in nature, right? But now I'm trying to think from the perspective of teaching practices as well as just curriculum developers as well. What curriculum shifts and teaching practices do you think would need to be made in order to at least advance our learners and encourage them to use AIs in the manner as cognitive partners, as you've just explained now, because they're already out there. Cognitive offloading is one of the biggest concerns with AI right now. So, what would be that shift that is necessary in our classrooms in order to change this narrative?
That's a really good question, Precious. I think one aspect that we have to do is we have to inform more learners about how AI really works. I think,
Mm,
unfortunately, AI is too much of a black box and people
true.
don't know how it works. So I think in this day and age, we really do need to do a little bit of, and we're never, for instance, I'm never going to know how AI works like a computer scientist knows, right? But I know a little bit about how it works. And that's really important. So it's not a totally black box for me. But more importantly, I think we have to help kids understand the ethics of using
Mm,
AI, and that when the whole purpose of schooling isn't just to hand in assignments. The whole purpose of schooling is to learn, to prepare students, to prepare individuals to be able to really take their place in society as a productive human being, both so that they can have a good life, but also to help our society have a good life. All people in our society have a good life. So we actually have to do some ethical training, both with teachers and with learners, about
mm,
the the harm that happens if they just go and use AI as an information source, because that's destroying the whole purpose of schooling. If AI can just give us our answers, why go to school? But the
True.
point is, we're going to be in the real world and we're going to face a situation where my little robot isn't going to be standing next to me and say, Joe, this is how you do that. I have to know how to do it. Right? I mean, what fun would it be for me to have a robot that I could say, hey, go make me a oak table. I need an oak table. So the robot goes to my workshop and makes an oak table. Okay. Well, what fun was that? I didn't do it. Right? We have to somehow create learning environments. I'm changing my point right now, but I think it's an important point. We have to create learning environments that show learners, that show students that learning is actually fun and valuable, not that it's something that's gruesome. Just like I wouldn't want my robot to make my table. I enjoy doing the woodwork. That's the whole point. Why would I want the robot to do it? And the same thing should be true at schooling. We need to put kids in situations where they really find the work that they're doing meaningful and valuable, so that they really prepare themselves so that when they're out in the real world and something happens, they can really respond, right? They're not always going to have an AI agent next to them that can actually carry out the task. And so we have to, we have to train, we have to basically educate learners on the ethics and the value of AI. And that when we, in fact, ask AI for information or to write the introduction to our paper, that's actually harming us. That's harmful. That's not helping us. And so we have to provide those kind of educational aspects. Now, there are good aspects to use AI. I mean, I often use it as a brainstorming partner. Not that I want it to give me an answer, but I say, I'm thinking about X, Y, and Z, and these are some of my ideas. What do you think of this idea? Do you have any other ideas? But it's a partner, right? That whole notion of how can it be a partner is really critical. So we need to get more examples of what AI can look like as this intellectual partner as we go about our day. Yeah, and so as I started off saying, I am a bit worried. I am worried about AI because we could end up being a very society that AI is a crutch for us, that we don't know anything. And we just always go to AI to ask it stuff. And if you think of where technology is going, we don't even have to type anymore. We can just speak into the computer.
Yes.
And so that's even taking more agency away from us, right? Because people don't know how to write; they just speak. And so I think it's really important to know how to write. And so we really have to, create these learning environments that give reasons for kids to want to learn, and not have the AI do it, right? You could think of a million different examples, right? Apparently AI can now create some pretty good songs. Okay,
Yes.
they might be good to listen to it, but if I'm the artist and I'm the songwriter, what fun would it be to go to AI and say, write me a song about love? Okay, but I don't get the joy, right? There is an element of joy. There's a big element of joy in learning, at least in my life. There's always been an element of joy in learning and doing new things. And I think we have to instill that in our students, that joy, that love of learning. And then I think using AI as an information source, as a crutch, partially is going to go away. Just like I wouldn't want the AI to write a song for me. I wouldn't want the AI to create a table for me, a little robot. I don't want to do that, because that's the joy. It's the joy of creating something that's valuable. And that's why project-based learning is so important. Because in project-based learning, we try to create these situations where kids will actually find meaning in what they're doing. It's valuable to them. It's valuable to their society. And those are the kind of situations we have to create. And that's what a project-based learning environment tries to do: create meaningful environments that really want to have kids learn.
Thank you so much. It is quite fascinating and impressive that there's so much more that AI can do. It's just how we use it that becomes an issue. And it really is disconnecting us from learning that actually matters. And that is one of the things that, from this entire conversation, that I've picked up to say you really truly value that learning actually matters and learners should engage actively in that. Thank you so much, Prof. Krajcik, for this very fruitful session and taking the time to be on our episode. We hope that in the near future we'll have more, looking at more advanced topics as well, and how this topic has progressed in our science education classrooms. Any final remarks in terms of what future and hope you have for science education before we close off the episode?
Well, Precious, I've always loved science for most of my life, and I hope that we can create classrooms that can bring that love uh, of science of learning to all children, and certainly creating learning environments in which kids are really exploring ideas, phenomena, problems that they really find important. I think is that is so critical in helping kids see that joy in learning. Learning is tough, but actually learning how to do anything is difficult, right? Becoming a good piano player, becoming a good basketball player, becoming a good soccer player, that takes a lot of work. But kids really spend hours at it, right? Think of the hours so many students spend on the soccer field. Why is that? Well, that's
Mm,
because they get joy in it. We have to
yes.
create learning environments that bring that same joy to kids, that they see a reason for doing this, they're engaged in doing it, and they want to do it. And we're starting to get the knowledge of how we can do that. So going back to your first question, which I didn't totally answer, there are other points I wanted to bring in. Creating environments that are motivating for kids by having interesting
Yes.
questions and phenomena for them to investigate is really critical. So,
That's true.
it's a really exciting world out there right now in science education. We really learned a lot. We have these
Yes.
new tools like generative AI, and it's a wonderful time to be an educator and to try to figure out how we can really create these environments that really can support all learners from a variety of different cultures in really truly developing deep learning so that they can apply those ideas in their own lives throughout their life. Anyways, thank you for having me on. I found it a very beneficial conversation. Thank you.
Thank you so much, Prof. Krajcik. We've learned a lot from you in this episode. And thanks again for tuning in into SteAM Ins and Outs podcast. See you in the next episode where we explore more conversations around science education and the entire STEAM interdisciplinary education. Thank you.